Fuck, this is ugly. Oh shit. Alright, I hope you can read. Okay, if not, I'll tell you. So, we have 10 million, and if we were to write that in base 7, what would the two last numbers be? So, okay, we'll do a quick recap. Okay, so in base 7, as in base 10, we can only use the numbers 0 to 6. So, okay, it has to be something between 0 and 6. Or the two numbers separately have to be somewhere between 0 and 6. So, how do we do this? Okay, so we'll think about this. Okay, if we have a number, say 121, the last number, which is then a 1, we can use 123. So we have 123. What is the last number? So what is 3 here? 3 is this number, the remainder, sorry. The 3 here is the remainder of this number with integer division or modulus 10. Because that's everything that's not divisible by 10. That is the definition almost for the last number. And what is then the second last number? Well, it's not quite the same actually. Okay, so we have 2, we have this 2 here. One would intuitively think that okay, well then it's the remainder after integer division 100, but then we get 23. So what we have to do is that we have to take this and subtract that and then divide it by 10. Yeah, exactly. It's basically, okay, how many tens fit in this with integer division 100, the remainder after integer division with 100. So what we have here is that, okay, so firstly we want to find 10 to the power of 7 modulus 7. Okay, so 10 is equal to 7 plus 3, so we can just rewrite this as 3 to the power of 7. And so then I'll just quickly scratch up the exponents for 3. Yeah, and that's as far as I want to go. So actually, we should do this. Okay, we should separate it as something times something. 3 to the power of, say, 1 times 3 to the power of 6. To make this easier in some way. So, okay, do we have any number here that's really close to being a multiple of 7? Well, yes, this thing here. That's 28 minus 1. So what is this? This is 3 times 3 to the power of 3 times 3 to the power of 4. And wait, I'll continue over here. And that is equal to 27 times 81. And that thing, modulus 7. What is this? This is just minus 1. So we have minus 81. Or actually, we can do it this way. Since 81 is 27 times 3, so then we just have that, okay, this is 27 times 3, this thing here. So we have that this is just minus 1 times minus 1 times 3, which is just equal to 3. Okay, so now we know that in 10 to the power of 7 days. In 10 million days, it will be, well, yeah, 3 days from now. The weekday, which is 3 days from now. So, just a fun fact. And then, so yeah, now we know that the last number in 10 million in written base 7 is 3. So I'll just write that down here. And then we have something here that there's more to it to the left. And then we basically do what we did here. So what we want is that we want 10 to the power of 7, the remainder of division, integer division, or modulus 49, 7 squared. Say that is, we call that A. And then we just want A minus 3, because it's the same thing, divided by 7. That would be our answer for the second last digit. So what the fuck is 10 to the power of 7 modulus 49? Well, we can do a bit of division. So we knew that 10 million modulus 7 was equal to 3. That means that it's something times 7 plus 3. Some integer times 7 plus 3. So we can just do this real quick. I can find out what 10 million divided by 7 is. We could just divide it by 49 and we would kind of get the remainder directly, but this is easier and better looking, I think. So yeah, I'll do that real quick. Means that 10 million is equal to 7 times this plus 3. So we can write it as plus 3 over 7. These two things are exactly, they are equivalent. And now we can just, okay, so we know that 10 to the power of 7, 10 to the power of 7 is equal to 7 times 140, no, sorry, 1,428,571 plus 3. And then, because we want the we want the remainder when dividing by 49, right? So we can just divide this by 7, this thing here that we got, and then we'll do some parentheses work, and then we'll basically be done. So yeah, I'll do that real quick. Okay, so what we get here at the last digit is 11 over 7, and that is 1 with the remainder 4. So that's 4 over 7. So now we can rewrite this thing as plus 3. Okay, so what do we have here? What have I actually written? So we have that we included that these two were equal before, and then I just switched this for this new term that we got. So this is 7 times this thing and then plus 4 here. So what is this modulo 49? Well, 7 times 7 is 49. So we can think about it this way. This thing cancels out. So what do we get left? We have 7 times 4, that's 28, plus 3, that's 39. And 39 is, well, yeah, exactly. We get 39. And that is our A here. It's 39. But no, what am I saying? Sorry, 31. 31. We get a 31. I'm fucking dumb. Alright, yeah, so we get a 31, and that's our A here. And what is 31 minus 3? Well, that's 28. And what is 28 divided by 7? That is 4. So so our answer now, because I erased the 3 before, is that the second to last integer digit is 4, and the last one is 3. And you can check this up. This is correct. I'm sorry for the confusion, but I hope you smart brains will figure it out. So yeah, what the fuck is that? Alright. So well, yeah, that was basically it. Quick lesson on digits and what the fuck not. So yeah, bye bye.